Hello everyone, welcome you all once again for this revision classes. In this revision classes, I am going to explain you some question answers from your question bank. Okay, at the same time we will solve some problems. Okay, so in this one, third unit, I am going to explain, that is basic kinematics. Let's start with first question, that is list the different types of constraint motion, explain any one. So here there are three types constraint motions we are having. Okay, in that one, first, completely constrained motion. Okay, what is that completely constrained motion? When the motion between a pair is limited to a definite direction, irrespective of the direction of the force applied, then the motion is said to be completely constrained motion. Okay, so here this one is the examples of this completely constrained motions. And examples where that completely constrained motions are to be used, like in piston and the cylinder in a steam engines. Okay, we are using, from the pair and the motion of the piston is limited to a definite direction. So here it is limited to a definite direction relative to the cylinder, irrespective of the direction of the motion of the crank. It is shown in figure 5.1. So 5.1, that is shown. Okay, so this one is, that is a completely constrained motion, we can say. Then second, figure 5.2 as well as 5.3, that is a completely constrained motion. Okay, definitely in one direction only it is fixed. Okay, irrespective of the direction of the force applied, that is said to be completely constrained motion. Then second, incompletely constrained motion. What is means incomplete constrained motion? Means when the motion between a pair can take place in more than one direction. Okay, we can use more than one direction, so then that type of motion is called as incompletely constrained motion. And example of this incompletely constrained motion is, it may either rotate or slide in a hole. Okay, so here that is shown. This one is the incompletely constrained motion. And third type, successfully constrained motion, means when the motion between the elements forming a pair is said to be successfully constrained motion, and such that a constrained motion is not completed by itself but by some other means, then the motion is said to be successfully constrained motion. So here, considering the shaft in a footstep bearings, that is shown in figure. So this is all about different types of constrained motions, and explain any one of it, they can ask. Okay, at that time you have to draw these diagrams and write the definitions, write the explanation regarding that one. Okay, so here I explained both that three types. Then second question, define kinematic link, briefly explain its types. So here, rigid link, in order to transmit the motion, the driver and follower may be connected by the following three types. Okay, there are three types we are using: rigid link, flexible link, and fluid link. Definition of those links. First one is rigid link, means a rigid link is one which does not undergoes any deformation while transmitting. That type of link is called as rigid link. And flexible link is one which is partly deformed in a manner not to affect. Okay, that type of transmission of the motion is called as flexible. Then fluid link, is one which is formed by having a fluid in a receptacle and motion is transmitted through the fluid by the pressure. Okay, through the fluid, with the help of that pressure only, that transmission will be taking place. That type of link is called as fluid link. Okay, so this question is for 5 marks, and you just go through the previous question papers. These two questions are very much common asked. Okay, so that's why you have to be aware of these things and do the practice. Then next, moving on to the next question, that is classification of the kinematic pair. Write the classification of the kinematic pairs. So here kinematic pairs may be classified according to the following considerations, and it is classified according to the some considerations. Which are those considerations? We'll see. According to the type of relative motion between the elements, the kinematic pairs according to that sliding pair, turning pair, okay, like that we're going to divide and see the rolling pair, screwed pair, spherical pair, like that we are having some considerations. According to that one only, that relative motion between the elements is to be considered. So this one is first step. Then second, according to the type of contact between the elements, the kinematic pairs according to that contact in between the elements, how that contact will be taking place, that will differs. First one is lower pair and second one is higher pair. What is lower pair? When the two elements of the pair have a surface contact, when the relative motion takes place and surface of one element slides over the surface of the other, then that type of pair is known as lower pair. In higher pair, when the two elements of a pair have a line or point contact, when relative motion takes place and the motion between the two elements is partly turning and partly sliding, then the pair is said to be this higher pair. Okay, so this is another type, another considerations. Then third, according to the type of closure, that kinematic pair is to be classified. Into that further divided into two types: self-closed pair and forced closed pair. When the two elements of a pair are connected together mechanically in such a way that only required kind of relative motion occurs, then that is known as this closed pair. Okay, in forced pair, when two elements of a pair are not connected mechanically but are kept in contact by the action of external forces, then that type of pair is said to be forced closed pair. Okay, so these are the some classification of the kinematic pairs. So this is for 10 marks. They will going to ask, write the classification of the kinematic pairs. Okay, so it is important for exam point of view. You have to give the more concentration on this one. Then next, moving on to the next question, definitions of structure and mechanism. Define the following terms, that is structure and mechanism. Structure, it is an assemblage of number of resistant bodies having no relative motion between them and meant for carrying the loads having straining action. Okay, this is all about structure. It is an assemblage of the number of resistant bodies, that is said to be structure, but there is no any kind of relative motion, that is said to be structure. For example, railway bridge may be there, roof truss and machines frames. Okay, these are the some common examples of structure. Then mechanism is nothing but when one of the link of the kinematic chain is fixed, then the chain is known as mechanism. Okay, one of the link of the kinematic chain is fixed, then that chain is said to be mechanism. It may be used for transmitting. For example, engine indicators, okay, and typewriters are the some examples. So these two definitions may ask for 5 marks. Okay, then moving on to the next question, define kinematic chain. Name the different types of kinematic chains. Kinematic chain means when the kinematic pairs are coupled in such a way that the last link is joined to the first link to transmit the definite motion. That is said to be completely constrained or successfully constrained motion, and it is called as kinematic chain. Okay, from first point to last point, which is interlinked, means that connection is should be connected. With the help of that one only, that kinematic chain is different. So following are the some three types of the kinematic chains with four lower pairs. 4-bar chain mechanism may be there, single slider crank chain and double slider crank chains. Okay, these are the some types of the kinematic chains are the importance. So this may ask for 5 marks. Then next, differentiate between machine and structure. Okay, this question asked so many times. You just go through the previous question papers. Okay, you come to know about this one. Differentiate machine and structure. For 5 or 10 marks he may ask. Okay, so here the following are the some differences between the machines and structures. Okay, we'll say the first one is the parts of the machine move relative to one another. Okay, whereas in structure do not move relative to one another. In structure it cannot move one to another, any relative motion will be taking place, but in machines relative motion will be taking place. Then second, in machines transforms the available energy into some useful work, whereas in structure no energy is transformed into the useful work. Third, the link of machine may transmit both power and the motion, but in structure what will going to happen? Why? The members of the structure transmit forces only. Okay, transmission of the forces only taking place. Then fourth difference, and these are the only 3 differences we are having. Okay, so this may ask for 5 marks. These differences you should read it carefully. Okay, then moving on to the next question. From this onwards, start with mechanisms. Okay, sketch and explanation, like that some questions will comes which are for 10 marks. You have to draw the diagrams and write that explanation of those mechanisms, how that works. So start with first one. Explain with neat sketch beam engine. Okay, so figure shows the beam engine. Okay, in this one cylinder is there, piston is there, and connecting rod we are having, and crank we are having. Okay, frame is there. Okay, so a part of the mechanism of a beam engine, it consists of so many parts like crank and lever mechanism. Okay, so it is also called as crank and lever mechanism. It consists of 4 links. Okay, it is shown in figure 5.19 in the mechanism. When the crank rotates about the fixed center A, okay, at the fixed center A, the lever oscillates. Oscillation will be taking place about the fixed center D. The end A of the lever CDE is connected to the piston of the rod, reciprocates due to the rotation of the crank. In other words, the purpose of the mechanism is to convert rotary motion into the oscillatory. So here that crank rotary motion will be taking place, that rotary is converted into this oscillatory. Okay, like that we are having the useful work from this beam engine. So here rotary motion will be taking place, and here oscillatory motion we are having. So this is all about sketch and explanation regarding beam engine. It may be asked for 10 marks. So it is important. Then second question, next question. Explain with a neat sketch coupling rod of locomotive engine. Okay, so here it is also called as double slider crank chain mechanism. Okay, you have to remember this one. So here 2 cranks we are having. two coupling rod of locomotive, double crank mechanism it is also called. And it consists of so many links like EAD and BC act as crank and connected to the respective wheels. The link rod, two cranks we are having in this coupling rod of locomotive. With the help of, if any one of the wheel starts rotating, another also starts rotating. So here it is the driver we can call, and if it starts with rotation, then obviously with the help of this kind of links, so this wheel also starts rotating. So that's why it is called as double slider crankchain mechanism. So for the purpose of this mechanism is to get the rotary motion to the rotary motion. You have to remember this point only, okay? And after that you have to practice this diagram, okay? This question this is for 10 marks questions, okay? You have to sketch and explanation practice. Then next, with a neat sketch explain single slider crankchain mechanism, okay? So here a single slider crankchain mechanism is modification of the basic 4-bar chain mechanism. It consists of one sliding pair and 3 turning pairs. It is usually found in reciprocating steam engines mechanism. This type of mechanism converts rotary motion into the reciprocating motion. So here through this rotary motion we can get the reciprocating motion in this piston, okay? So with the help of this kind of links, that rotary motion to the reciprocating motion we are getting. So for that reason we are using this kind of single slider crankchain mechanism. The only thing is that you have to practice the diagrams, and once you understand the concept of working of the single slider crankchain mechanism, you can write in your own words. Initially this crank starts rotating. With the help of this kind of additional attachments we are getting this reciprocating motion. The only thing is that what type of advantage we are having from the different types of mechanisms, that we should understand first, okay? In this single slider crankchain mechanism we are getting rotary motion to this reciprocating motion, okay? So rotary it will takes like this, and oscillatory like this. Then next, moving on to the next question. So this is further explanation regarding that single slider crankchain. You just go through the notes, you come to know, okay? Which part does what the things like that, it is given. Then next, with a neat sketch explain bull type engine. So this is the diagram of the bull engine. In this mechanism the inversions is obtained by fixing the cylinder, okay? Inversions will be taking place by fixing the cylinders, and that is shown in the figure. In this case, when the crank rotates, the connected rod oscillates. So here what happens, if the crank starts rotates, this connecting rod oscillation will be taking place about the pivoted to the fixed link 4, okay? 4 at A. The piston attached to the piston rod reciprocates. So duplex pump, which is used to supply feed water to the boiler, have 2 piston attached to the link 1. It is shown in figure clearly, okay? For that purpose only this type of bull engine we are using. So whenever this crank starts rotating, so with that connecting rod starts oscillation. At that time only reciprocation will be taking place inside the cylinders. This is all about bull type engine. This may ask for 10 marks. Then next question, with a neat sketch explain elliptical trammel. So this is the diagram of elliptical trammel, and explanation regarding that, it is an instrument used for drawing the ellipse. This inversion is obtained by fixing the slotted plates. It is shown in above figure. The fixed plate or the link 4 has 2 straight grooves to cut in it at right angles to each other. The link 1 and the link 3 are known as sliders. So here link 1 and 2 are called as sliders, which slides inside that grooves. So here which forms a turning pair. With the help of that one only we are getting the turning pairs with link 1 and 3. When the link 1 and 3 slides along their respective grooves and the point on the link 2, such a P traces out an ellipse on the surface of the link 4 is shown in the figure. So here a little consideration will shows AP and BP are the semi-major axis. So here into this grooves, this part starts reciprocates, okay. With the help of that one only, that circular intersection we are getting. So this is all about elliptical trammel. This may comes for 10 marks. Then next, moving on to the next question, that is, with a neat sketch explain Scotch yoke mechanism. So this is the Scotch yoke mechanism shown in the figure. So crank is fixed, crank is connected, and sliding action will be taking place with the help of that sliders, which is connected to the crank, and one end of that link is connected to the piston rod inside the cylinder, okay. That is reciprocation will be taking place. So with all aspect of this one, the mechanism is used for converting a rotary motion into the reciprocating motion will be taking place. So main intention to get a reciprocating motion through this rotary motion from this Scotch yoke mechanism. So here what happens, the inversion is obtained by fixing either the link 1 or 3. 1 or 3 is to be fixing, okay. That is clearly shown in figure, which is fixed in this mechanism. When the link 2 rotates about B center, the link 4 reciprocates. The fixed link 1 starts guiding the frame. So this is all about Scotch yoke mechanism. The only thing is that rotary motion will be taking place whenever it connects to the crank, okay. Crank, this one is crank. So whenever starts rotary motion, so that one end of that crank is connected to this slider. Inside that slider grooves are maintained, and one end of that slider is connected to the connecting rod inside the cylinder. So whenever this crank starts rotating, that with the help of this connecting rod, reciprocation will be taking place inside this cylinder, okay. So that's why finally we are getting rotary motion to the reciprocating motion through this Scotch yoke mechanism. Like that you have to write the explanation after drawing the sketch. This may ask for 10 marks. This is important for exam point of view, okay. So these are the some theory questions. I think this chapter includes everything theory, okay. No any problems will comes, no any problems are there. So you have to practice the sketches regularly, then only you are going to get, because the syllabus is somewhat lengthy as compared to other chapters, okay. Classification is there, types are there, advantages are there, differentiations, difference we are having, and some sketches, explanation, some definitions we are having. Like that we are having the so much of theory parts. So that's why you have to study regularly. This is all about basics of kinematics. Exams may announce at any time, so do the study regularly. If you have any doubts, you call and clarify the doubts, okay. But don't option for that studying, lack of studying. So study regularly. Thank you all. Thank you. See the videos regularly and do the study regularly. Okay. Thank you. Thank you one and all.